So we're starting inequations or inequalities. So there's a difference between equations and inequations or inequalities. Equations have got an equal sign between the terms or numbers. Well, inequalities have other symbols which are called symbols for inequalities, which are greater than, less than, and the likes. So in equations or inequalities, compare the values of two sides. That's the thing. They don't state that the two sides are equal, but they compare. They can tell you which side is greater than the other, or which side is less than the other. So the symbols that are used in inequalities are this one, which is less than. So I don't know how that is possible. I remember when I was learning mathematics when I was young, it was hard for me to know if this is less than or greater than. But now I can just tell how this side is small and this side is big. So whatever is this side is smaller than whatever is this side. So if you want to read this, let's say there was 2 here and here there is let's say there is x here and here there is y. So x is less because this is small. X is less than y. So that's how I read this. X is small than y. That's what this means. It means this other side is bigger and this other side is small. So x is less than y. The other one is this, greater than. This side is bigger than this side. So x is greater than y. X is greater than y, which is this greater than here. The other symbol that is used is the combination of less than or greater than and an equal sign. So if something is less or equal, then we use this one, less or equal. So this line here is for equal. So we say something here is less or equal to something here. Then this is greater than. Something here is greater or equal to this side here. So these are the symbols we use in inequalities, just 4 symbols. So inequalities are just dealt like linear equations where you solve for the unknown or where you make x or y depending on the letter that they have given you the subject. There's only one exception. So the exception is when you divide both sides by a negative number, the symbol changes. So division by negative number reverses the sign. What reversing the sign means is less than will become greater than, or greater than will become less than, less or equal to will become greater or equal to, and greater or equal to will become less or equal to. That's what it means. So when you divide by negative number, this becomes this. You just reverse the sign, and this becomes this. Also, this becomes this, and vice versa. So that's the golden rule of inequalities. This only happens when you divide both sides by a negative number. So this is what I'm from explaining. This will change to this and vice versa, and this will change to this and vice versa. So let's do a demonstration where you see how the change happens and when to apply the change or when not to apply the change. We'll start with the straightforward example where we don't apply the change. So you can have something like this. Ax is greater than b. So your job is to solve for x. You do that by dividing both sides by a. So if we divide by a, we're going to have the a cancel here. So we're going to have x greater than b over a. So as you can see, the symbol is just the same. I've divided by a. A is not a negative number, so nothing changes. But if a was a negative number, this could have changed. It could have turned into less than. So this is a good example of where it changes. Negative ax greater than b. So negative ax, we divide both sides by negative a. So negative a and negative a are going to cancel. We're going to have x here, and this side negative a won't cancel because there's no negative a on top or a on top. But the fact that we've divided by negative both sides, this reverses. It becomes less than. It was greater than, now it's less than. So that's the golden rule. So whenever you divide by a negative number, just remember that you have to reverse the sign. So another skill that you have to learn on inequalities is to illustrate your inequality on a number line. So how do you illustrate? To illustrate is to show. For those who are not who are not so inclined with grammar. How do you show your inequality on a number line? So x greater than 3. Let's say after you solve, you get x is greater than 3. How do you show this on the number line? And x is greater or equal to 3. How do you show this on the number line? These are the most important thing to learn. The difference between greater than and greater or equal to. The same will apply for less than and less or equal to. So we'll start with x greater than 3. So for greater than 3, first, this is our number line that we're going to use for demonstration. So for greater than 3, we use this open circle. What does it mean to be an open circle? So it's a circle, as you can see, but it is open inside. That's what we use for greater than and less than. So long as we don't have equal to here, we use this. So we put this on this number here. So here is the number 3. So on top, we write an open circle and we draw a straight arrow that goes to all the numbers greater than 3. So we just drew the open circle on top of 3, which is this 3 here, and this is saying x is greater than 3. So we show by an arrow that all these numbers this side are greater than 3. So this is your answer. The arrow, as you can see, has got this kappa. This kappa shows that this arrow goes forever. So you can end it anywhere, it's okay. You don't have to end it at any specific number, because this part here, the arrow, just shows that it goes forever. Even on the number line, the arrow shows that there are numbers here, but we just don't want to indicate them. So even when you are drawing the arrow to show your answer on a number line, just make sure that you draw the arrow of any size, doesn't matter. So this is how to show your answer on a number line. So if it was x is less than 3, so after we draw a circle on 3 and an open circle on 3, we ask ourselves which numbers are less than 3. These numbers are smaller than 3 as compared to these. So we draw an arrow that goes this side. So what about greater than, or what about greater or equal to? What's the difference between greater or equal to and just greater? So the difference is, on greater or equal to, we use a solid circle. A solid circle is one that's not open in the middle like this. So we make sure that it is we shade everywhere. So x is greater or equal to 3. So we put this on 3 and we look at this. Is this greater or less? So if it's greater, we go to numbers that are greater, and if it is less, we go to numbers that are less. So this is the big difference between the two. So this one has no equal to, so it's open circle, and this one has equal to, so it's a solid circle. So we draw something like this. So here, then we draw a line showing all the numbers that are greater than 3. And if this was less or equal, then we could have gone this side. So this is the big difference. So what does it really mean? When you say x is greater than 3, then the numbers that, because x is, we don't know what x is, it can be any number. So for inequalities, x is greater than 3 means any number that is greater than 3. So all these numbers are greater than 3. So the numbers we're interested in are numbers like 4, 5, 6, 7, 8, 9, just like that, not 3, because we're looking at numbers which are greater than 3. So we say 3 is excluded from the inequality. What to mean is, this actual 3 is not what we're interested in. We're interested in the numbers greater than 3. Then the other one, which is greater or equal to, which is represented by a solid circle, is called inclusive, as 3 is included, which means we're interested in the numbers 3 and numbers greater than 3. That's why it's x is greater or equal to 3, which means x can be 3 or it can be any number greater than 3. So we're interested in this 3, which means 3 is part of our answer and all the numbers greater than 3. Why am I saying this? Because in an exam, sometimes they ask, what is the smallest number that x represents? So if they ask that, for example, for the first one, what is the smallest integer? Remember, when we're in types of numbers, we defined an integer as a number without a decimal, if I put it in simple terms. But of course, it was defined as positive or negative number, including 0. Sorry, I mean positive whole number or negative whole number, including 0. So a whole number doesn't have a decimal point. So in an exam, they like to ask, what is the smallest integer that x can represent? So x is, there are many numbers that can represent x. Any number that is greater than 3 represents x. But what is the smallest? So we know that the inequality starts from here, it goes this side. But since it's greater than, 3 is not included, which means the smallest number is 4. The highest number we don't know because it keeps on going, but the smallest number is 4. Why? Because 3 is not included. But in the second case where it says greater or equal, which means we start from 3. 3 is included and the smallest number is 3. I mean the smallest integer is 3. So that's the difference. Be careful with this. You are going to encounter this. So in conclusion, an open circle is for greater and less than, which shows exclusion, meaning that the number where we're starting from is not included, it's excluded. Then a solid circle is for greater or equal to and less or equal to, which shows inclusion, which means the number is included. Let's do an example. Solve the following inequalities and show on the number line. So I've got these two inequalities here. 2x plus 3 greater than 8, negative x over 3 less or equal to negative 2. So we're going to apply everything that we have learned so far. So we'll start with the first one. 2x plus 3 is greater than 8. So just solve for x. So take 3, the other side becomes negative 3. Then we have 2x greater than 5. We divide both sides by 2. And 2 is a positive number, so nothing changes. So on the here, 2 is going to cancel. And this side, we're going to have 5 over 2. Or 2.5 or 2.5. So we have solved the inequality. The next issue is, of course, you can take this into a mixed fraction. 2 divided by 2 into 5, 1, remainder 1 over 2. Yes, but for inequalities, I would encourage to express it as a decimal. So how do you express it as a decimal? It's simple. Just divide this into this. 2 divided by 5, you're going to have 2. Then remainder 1. Then 2 into 1, it can't. You put a point after 2, and you put a 0 after 1, becomes 10. 2 divided by 10, it's 5, so it becomes 2.5. We did this, if you can recall how to change, for those who are lucky, we did how to change fractions to decimal fractions and the likes. So x is greater than 5 over 2. So how do we illustrate this on the number line? So x greater than 5 over 2 is just the same as x is equal to 2.5. So you ask yourself, where's 2.5 here? So 2.5 is between 2 and 3. So it must be here. This is where we're starting on top, because there is no equal to. We put that open circle. And greater, it means all numbers which are greater than where we're starting from. So all these numbers. This is our answer. B, negative x over 3 greater or equal to negative 2. So here, how do we solve for this? We first cross multiply, or for those who like doing that, we can put over 1 here. But it doesn't change anything, it's just a formality. So now that you have solved a lot of questions, you can just do cross multiply and be able to see your invisible 1 here. So x divided multiplied by 1 is going to be x, and 3 divided by negative 2. I mean negative x divided, negative x times 1 is going to be negative x, and 3 times negative 2 is going to be negative 6. So we're going to have this negative x times this invisible 1 here. It has given us negative x, and 3 times negative 2, it has given us negative 6. Next, we divide both sides by negative 1. So we divide so that we want to remain with x here. So when you divide both sides by -1, the negatives are going to cancel, and here the negatives are going to cancel, going to have 6. But division by negative means the sign changes. So I'm going to have this x is this or equal to 6. So the next job is to show this on the number line. So we can draw a number line here and we ask ourselves, where is 6? 6 is here. And on top, we have to put either an open circle or a solid circle. So this has got equal to, so it's a solid circle. And less than are numbers that are smaller than 6 this side. So we can draw like that. Solid circle on top of 6 and an arrow that shows numbers that are less than 6. Meaning that if somebody could ask us what is the smallest number being represented, what is the smallest integer being represented by this inequality? Of course, so of all these numbers, which one is small? It's hard to tell because all these numbers are small, so we cannot tell. There's no answer to that. But if they ask us what is the greatest number represented by this inequality, so the biggest of this is 6. 6 is included. If there was no equal to, then it could have been 5 because 6 is not included. Then there is another interesting inequality that tends to come, which is called double inequalities. It's like simultaneous equation, but it's not. It's double inequalities. So they give you an inequality with two symbols in between. How do you tackle it? So double inequalities are inequalities with two inequality symbols in them, like this. So -2 plus x less than 3 minus x greater than 4x plus 1. So how do you solve this? How do you do taking to the other side and stuff? So there are basically 2 steps or 3 steps to deal with this. The first is you separate these. How do you separate them? So you make sure that you write with one symbol. So how? You write everything including the first symbol. When you meet the second symbol, you stop. So we write everything here up to here because I've made the second symbol. And we do then again we do the same, but this time we start from here. We write everything after the first symbol, and up to here we stop. The second symbol we that's where we stop. So we write everything from -2 to x and everything from 1 to 3, like so. So we have got -2 plus x less than 3 minus x here. Then again we'll start from here. 1 plus 4x greater than x minus 3. X minus 3. So 3 minus x greater than 4x plus 1. Once we do this, we go to step 2. Step 2. Solve each of the inequalities separately. So you solve each of the inequalities separately. So here's how to solve them separately. So there's this and there's this. So we start with this one. -2 plus x, 3 minus x. So like terms together, the negative x will go this side and -2 comes this side. And we're going to have this x, this becomes plus and becomes x plus x. And this one 3, -2 goes this side, becomes plus 2. So x plus x is going to give us 2x less than 3 plus 2 is going to give us 5. We can divide both sides by 2. We're going to have x less than 5 over 2. The other side we do the same also. Like terms, 4x goes this side, it becomes -4x, and 3 goes this side, it becomes -3. So -x, -4x, it's -5x. 1 minus 3 is going to give us -2, like so. Then we can divide both sides by -5, and we're going to have x x greater than 2 over 5. The symbol has changed because of the division by negative. So x is greater than 2 over 5. So maybe usually after you do this, we have solved the inequality, but sometimes they can ask you to demonstrate on the number line. Or actually, they can ask you what is the smallest number, the smallest integer and the greatest integer that the original inequality represented. For you to know that, you have to go to the next step, which is you represent the inequalities on the number line, and after that, you identify the numbers. So that's how they usually ask. during an exam, they don't ask illustrate on the number line. What they ask is, what is the greatest integer represented by this, or what is the smallest integer represented by this inequality, which means the only way you can tell is drawing a number line. So we have these two answers. Like I said, remember what I said, it's better you represent them in decimals because fractions might be difficult for some of us to understand. So 5 over 2 is 2.5, 2 over 5 is 0.4. If you remember again, this one I explained, 2 into 5 is 2, remainder 1. Then 2 into 1, it can't, so you put a point here and you put a 0. Behind 1, it becomes 10. 2 into 10, it's 5. The same here, 5 into 2, it can't, so it's 0. And you put a point here, and you put a 0 just behind 2. 20 divided by 5, it's 4. So 2.5 and 0.4 are numbers that I used to understand. 2.5, it means it's 2, then somewhere between 2 and 3. 0.4, we know that it's near 0.5. 0.5 is between 0 and 1, and just a bit behind. So we can just approximate where 0.4 is on the number line. So draw a number line. We start with this one, x less than 2.5. So 2.5, it's somewhere here. So here, that's where we're going to have an open circle because there is no equal to. And x greater than 0.4, 0.4, 0, and 1. So in the middle, it's 0.5. So 0.4 can just be somewhere here. So on top, that's why we put x is greater than 0.4. And the greater means the numbers that are here. Even this for this one, less, it means 2.5, but this side. So we're going to have 0.4 there and 2.5 there. And on top, we can draw for 2.5 an arrow like this. And on top of 0.4, we can draw an arrow like this. They are all open circles because no equal to. So this region here, you can even shade it to show. Of course, if they're interested, if they say show this on the number line, you can even shade this region in between, not including this part where the open circle, because we're not interested in this part in 0.4 or 2.5. We're interested in numbers greater and numbers less. So this common region here is the region of interest. The region between the two arrows is the region of interest. So start from here, going this side till where the other arrow starts here, but not exactly, just a bit behind. So this region here is the region of interest. So if we want to find the biggest integer that the inequality represents, so ask ourselves, in this region, what is the biggest integer? What is the greatest integer? How many integers are here? So we can see that it starts from here, 0.4. So we don't include 0.4 because it's an open circle. So we have 1, okay, another one is 2. So I've got two integers here, 1 and 2. And we end here on 2 because 2.5 here is not included because of the open circle. If it was a solid, we could have included here, but still 2.5 is not an integer. So still, we end up with 1 and 2 as the only integer being represented, as the only integer has been represented by the inequality. So if the question says, what is the greatest integer? Which one is bigger between 1 and 2? It's 2. And what is the smallest integer? It's 1. So the largest integer represented by the above inequality is 2 and the smallest is 1. So this is how to deal with inequalities. Hope you have found this funny. And this is where we end. Make sure you like, subscribe, and share where applicable. And happy solving.